Heritability estimates is a proportion of observed variation in a particular trait that can be attributed to inherited genetic factors in contrast to environmental ones. This has two definitions. The first one was a statistical definition. Defines heritability as the proportion of phenotypic variable attribute to genetic variance. And this has two definitions. The first one was a statistical definition. Defines heritability as the proportion of phenotypic variable attribute to genetic variance. And the second definition is more common-sensical and defines heritability as the extent to which genetic individual differences contribute to individual differences in observed behavior. The concept of heritability plays a central role in the psychology of individual influences. It analyzes the relative contributions of differences in genetic and non-genetic factors to the total phenotypic variance in a population. It measures the fraction of phenotype variability that can be attributed to the genetic variation. Heritability can change without any genetic change occurring. Estimating heritability. Any particular phenotype can be modeled as the sum of genetic and environmental effects. Phenotype P equals genotype G plus environment E. The variance in the trait bar P is the sum of the genetic effects as follows. Bar P equals bar G plus bar E plus COV GE. In a plant experiment, COV GE can be controlled and held at 0 in case heritability is defined as H2 equals bar G var P. Broad sense heritability. It reflects all the genetic contributions to a population's phenotypic variance, including additive, dominant, and epistatic multigenic interactions, as well as maternal and paternal effects where individuals are directly affected by their parents' phenotype. The additive genetic portion is known as narrow sense heritability and is defined as H2 equals var A/var P. Additive variance is important for selection. Since only P can be observed or measured directly, heritability must be estimated from the similarities observed in subjects, varying in their level of genetic or environmental similarity. The statistical analysis required to estimate the genetic and environmental components of variance depend on the sample characteristics. In non-human population, it is often possible to collect information in a controlled way. Studies of human heritability often utilize adoption study designs, often with identical twins who have been separated early in life and raised in different environments. A second and more common design is the twin study, in which the similarity of identical and fraternal twins is used to estimate heritability. Heritability estimates are always related to genetic and environmental factors in the population. Heritability can be made larger by diversifying the genetic background. Estimation method. There are essentially two schools of thought regarding estimation of heritability. A school of thought based on the analysis of correlations and by extension. Regression. Path analysis is based on the analysis of variance of breeding studies using the entacross correlation of relatives. Various methods of estimating components of variance from ANOVA are used in this analysis. In selective breeding of plants and animals, the expected response to selection can be estimated by the following equation: R squared equals H squared S. In this equation, the response to selection R is defined as the realized average difference between the parent generation and the next generation. The selectional differential S is defined as the average difference between the parent generation and the selected parents. The above equation is equal to the ratio VAR/A/P only if the genotype and the environmental noise follow Gaussian distributions.